Hi, welcome to online tutorial series on Arduino and IoT. So in this lesson we will be making a project based on whatever we have discussed till now. So the project title will be, it is a very easy project. The project will be obstacle avoider robot. So it will be using DC motors and IR sensor. These are the concepts which we have discussed in our last 2 to 3 videos. Okay. Further, we also provide online training, help in technical assignments, and do freelance based projects based on embedded system, MATLAB, LabVIEW, Python, machine learning, etc. So if you have any such requirement, then you can contact us at through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. Okay, so let's start with the theory part of it. So our simple project is obstacle avoider robot. So I hope you may be familiar with this. So let's have a brief intro about it. So suppose if you have a robot and there are few obstacles around it. So your task is to navigate without touching these obstacles. Okay, so that your robot can be navigate freely without touching these obstacles. Let's say obstacle 1, obstacle 2 and obstacle 3. So this is the simple concept of the robot. So now if we talk about this, one thing should be know, we should have some mechanisms through which we should robot should came to know, okay, there is a obstacle in front of it. So remember in our last class we have talked about IR sensors which can act as a obstacle detector. Okay, so if there is a obstacle in front of it, the sensor will provide 1, and if there is a free path, sensor will provide 0. Okay, so that means we will be using this IR sensor. Another, for moving part, we will be using DC motor, and we also have discussed how to interface our DC motor to the Arduino. So now let's have a robot structure which we are going to make. Okay, so it will be very easy, or a very basic robot structure, so not very hi-fi. Okay, so we have two IR sensors placed in front of it, that is IR1 and another is IR2. Okay, so there are two IR sensors are there. Okay, and then we have two DC motors which are connected, okay, to the wheel, so it provides the motion to it. So let's say we have this M1, and let's say this is a motor M2, and then we have our Arduino Uno board, okay, which is used to control these boards. And further we have also a motor driver IC which is L293D, because as you know, we can't interface these connections of this DC motor to the Uno directly. Okay, so this is the basic structure of our robot. Okay, now if we talk about the pin connection diagram, okay, so prior to pin connection diagram, let's understand the concept. So concept is simple. If no obstacle is there, okay, no obstacle, robot should move forward. We can say forward movement. Okay, now suppose a case obstacle is in front of the IR sensor 2, that is the right part of it. Okay, so we can say right obstacle. So what should it do? It should turn left. So how can it turn left? If we stop motor 1, stop motor 1 and on motor 2. So if this particular motor is stopped and this particular motor is moving, then it will start turning left for right obstacle. Now let's say if we have left obstacle, now there is an obstacle in front of it, so it should turn right. So in order to turn right, very simple, if we make this particular motor stop M2 and turn on the motor 1, it will start turning right. Okay, so let's say on motor 1 and stop motor 2. Now there could be a case obstacle. Okay, let's where is let's say obstacle in front of both sensor. Okay, that means both sensor IR1 and IR2 are giving 1, so which should turn back. Okay, so turn back means reverse both the motors, motor 1 and motor 2. Okay, so this is very quite easy. Okay, if there is no obstacle in front of the IR sensor, it should move forward. That means motor 1 and motor 2 should be moving in forward direction. If there is a right obstacle, it should turn left by stopping this motor 1, and if there is a left obstacle, it should turn right by stopping motor 2, and if there is a obstacle in front of both the sensor, then that indicates there is no path to move forward, so it should turn back, and after that it should turn right, turn back, and because if it is turning back and if we are not making it to right or left, it will stuck in that position, so it should turn back and turn right or left, so that is random, so it's 2. So if there is in front of there is an obstacle in front of both the sensor, that indicates there is no path in front of it, so it should turn back and then it should turn right or left, and when both sensor will be giving 0, it should start moving in the forward direction. That will happen automatically. Okay, so this is the very basic logic behind it, and now we will go through the connection diagram, how we have made how we have connected these sensors and these motors to the Arduino pin, so that we can move forward to writing the program. Okay, so we have, this is our Arduino Uno. Okay, so IR sensor 1 is connected to pin number 2, IR sensor 2 is connected to pin number 3. So this is IR1 and this is IR2, and then there are two motors. Okay, so a motor 1 is connected to 4 and 5, and motor 2 is connected to 6 and 7. And obviously it is going through this L293D circuit, L293D. Okay, so the connections are, this is pin number 2 and this is pin number 2, 3, 4, 5, 6, 7. This is pin number 10 and this is pin number 15, and then we have two motors here. This is motor 1 and this is motor 2. So I hope you already know the pin diagram of this L293D. So this is pin number 3 and this is pin number 6 and this is pin number 11 and this is pin number 14. because 12 and 13 will be 3. Okay, so if there is any mistake in this pin diagram, you can go through the data sheet and you can go through our previous lecture. Okay, so this is very simple. Now there is a cache here, like suppose if you have there is no sensor and no obstacle in front of sensor and your motors are moving in opposite direction, so you simply can change the polarity of the connection so that it starts moving the forward direction. So that is a kind of calibration which we need to do, because as we have discussed, we are prior to connecting it, we don't know in which direction motor will be moving. Okay, so if there's no once you make this robot check out when there's no obstacle, so all both the motors should move in the forward direction. If any one motor is moving in reverse direction, you just need to change the polarity of that motor and then it will start moving in the same direction. Okay, that's a small thing you have to do. Okay, so now I think we know the concept, we know the logic, how to make it, and we know the connection diagram. Now let's have a look at the hardware which we have made, and then we will move to the programming part of it. Okay. This is the chassis for our robot. In this we have connected two DC motors. So this is first DC motor and this is the another one, and these are two wheels. So these have been connected with a single configuration, and right, and at the third position we have a caster wheel so that it can move freely in forward direction. Okay, so now we will be connecting two IR sensors at these positions, and then we will put a motor driver IC and Arduino Uno controller circuit on this board so that it can move freely. Now we have connected these two IR sensors and we have put some wrapper or kind of lamination so that it don't get short circuit due to metallic surface of this chassis. Now we will put Arduino Uno and a motor driver circuit and we will attach to this chassis board. We have connected this Arduino Uno and this is the motor driver circuit. So now we have connected these two, and we have also put a general purpose breadboard, a slide kit, so that we can put a common VCC and common ground so that it can be used to provide VCC and power supply to these IR sensors and to other components we will be adding them. Okay. So now we will make connections and then we'll have a video. Finally our connections are ready. It looks a little messy. This is IR sensor 1, this is IR sensor 2, and this is motor 1 and this is a motor 2. So VCC and ground of both the IR sensors are connected to this common VCC and ground, and then the output of the IR sensor is connected to pin number 2 of this Arduino Uno, and output of this IR sensor 2 is connected to pin number 3. This motor, two pins of this motors are connected to pin number 4 and 5 to the Arduino, and motor 2 connections are connected to pin number 6 and 7 to this Arduino. And then we have provided this VCC and ground of this L293D circuit module to this power rail to VC corresponding VCC and ground. So let's write a code for this and then we'll have a test. Okay, so you have seen the hardware part. Now let's write a program for the same. Okay, so let's arrange the things. Here we have Arduino IDE, so let's create a new sketch and close this old one. Okay, first thing, let's save it at desktop. Let's say project 1. Okay, now let's define our pin. Okay, int These are IR sensor pins, and we'll defining the motor connections. Okay. So these are IR sensor pins, these are motor connections, and these are the variables which we have used to store the data, which will be reading from the sensor status. Okay, now we'll be setting the pin mode. So these two pins has to be an input type, and all these remaining pin will have to be as output type. Okay, so let's write it. Okay, it seems fine. Now let's write the code. First thing we'll be doing, we will be reading the status of the sensor. Okay, and only then we'll be sending the corresponding command. Okay, so uh, let's read the status of the sensor 1 and 2 in variable a and b. Okay, so status of both the sensor is in A and B. Now there are two states, so there could be four cases could be there, 0 0 0 1 and 1 0. So we'll go one by one. So if first we'll go write a case when no obstacle is there. When there is no obstacle, this A and B will be giving 0. Because we need to check both the condition. If A is 0 and B is 0, only then this case will run, right? Because when there is no obstacle, both the sensor will be giving 0. So in if statement, we have to check both the conditions. Only then we can move forward. So uh, now we will set the motor pins or the direction of the motor. In this case, both the motors should run in the forward direction. Okay, so we will assume like connections are fine. So we'll send so digital write. Okay, so we are making one pin high and one pin low of motor 1. Similar we will do for another motor. And if you find it difficult, you just need to change the polarity on the hardware. It's fine, both the motors, right? Now check the another condition. So this is the case when, because A is the IR1 sensor, so let's check from it. This is a case when there is an obstacle in front of IR1, that means there is a left obstacle. Okay, so in this we need to turn right. So let's make it, it is left obstacle, so turn right. RIGHT. So in order to turn right, what we need to do, we need to on motor 1 and stop motor 2. Okay, so let's on motor 1. Okay, so this should turn on and motor 2 should turn off. Okay, so when there is a left obstacle, it will be turning right. Okay, now another case could be right obstacle. So we should turn left. So right obstacle means A is giving 0 and B is giving 1. So it is a case because IR sensor 2, so this is a right obstacle. Now we should turn left. In order to turn left, we should make this motor 1 off and motor 2 on. Okay, so let's do this. Okay, so we should turn off the motor 1, turn off the motor 1 and motor 2 is on. Okay, now else case means when both the sensors are giving 1, that means obstacle. Okay, so we can write it like no path. So in this case both the motors should turn back. Okay, so we need to change the direction of this one. Okay, it has turned back, and then we'll need to move left or right. So let's say we are moving it to left. Okay, and then so it is not necessary you make it turn left, you can also make it turn right. And so turn left is we should stop motor 1 and turn on motor 2. Okay, now there is one more thing. We need to provide some delay in turning left or right, because if we are not providing delay, it will move a slight and then again it will start moving forward. So we'll provide a delay of let's say 1 second in each turning left or turning right. Why we are not providing a delay in moving forward? Because if we provide it, sometimes it bumps into the obstacle if we provide delay. So we are providing delay only during this back operation or turning left or right operation. Okay, now let's, so it will give sufficient time for the robot to come out in the range, come out from the range of obstacle. Okay, so it seems fine. Let's have a look. We have set IR1, IR2 motors input as output, and then if there is no obstacle, it is moving forward, and if there is an obstacle, then it is turning left and right. Okay. Left obstacle, turn right, right obstacle, turn left. fine, and then if there is no obstacle in front of it, it is moving back, and then it is moving left. Okay, that's fine. Now let's compile it, and then we will upload the program on the hardware. Okay, so let's upload the software. Now let's upload the software to the robot. Okay, it's uploaded. Now let's test it and see how it is working. Okay. It tries to find its direction, but the main concept, it is changing its direction as soon as some obstacle in front of it's evident. Just try to find a way in between it. Okay, so let's see it again. It changes the direction, tries to find the way. So this is a very crude robot, road obstacle avoidance robot. You can increase the sensitivity of this robot by by adding more AR sensor to it, or by changing our programming a little bit. Okay, so you have seen how this robot is working, and it's working fine, and I hope it's fun for you. So you can make this robot at your home, and if you have any doubt or any suggestion, then you can let us know by commenting below this video. I really hope that you liked this video. So if so, then please subscribe to us for more such kind of tutorial videos. Okay. Further, we also provide online training and help in technical assignments, and do freelance based project based on embedded system, MATLAB, LabVIEW, Python, data science, and machine learning. So if you have any such requirement, then you can let us know by, or you can let us know by visiting our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. So that's it for this video. Thank you.